Okay, welcome back again for part 2 now in chapter 10. Ethernet is a way of connecting these computers in that local area network, or LAN as we called it. It has been the most widely used method of linking computers together in LAN since the 1990s. The basic idea of its design is that multiple computers have access to it. It can send the data at any time, right? So Ethernet refers to this hardwired connection between computers, most commonly using types of cables. It's beyond this course, but it's Cat5e or Cat6 copper cables. Now, Wi-Fi wireless connection is served by an Ethernet connection between your Wi-Fi router and the internet modem. But the Wi-Fi itself is not considered the Ethernet. Now, there's such a thing as a token ring. This is a computer networking technology used to build local area networks. So it uses a special 3-byte frame called a token that travels around a logical ring of workstations and servers. And the token ring was introduced by IBM in 1994, standardized in 1989 by IEEE 802.5 if you're interested, but probably not at this point. Now, TCPIP stands for Transmission Control Protocol, Internet Protocol. TCPIP is a set of standardized rules, right? These are all about standardized rules to make communication work that allow computers to communicate on a network such as the internet. So the internet works by using this protocol called TCPIP, again, Transmission Control Protocol / Internet Protocol. So in basic terms, TCPIP allows one computer to talk to another computer via the internet through compiling these packets of data and sending them to the right location. Now, when a computer sends data over the internet, the data is divided into these packets, and I show you a packet at the bottom of the slide. Each packet travels along the fastest available path to the recipient's computer or server via your router, or a series of routers, actually. So step 1 on the top left picture, which is also found in your book. Step 1 is to use the communication software like your browser. And with that, you've requested a web page on your screen. So next, the computer is going to use TCPIP, that standard, to establish this connection with the web server on the other end in the network, this wide area network. And routers send the packets over the internet from the web server back to your computer. Now, this is really beyond this course, but I do think it's interesting. So the following information is something that I thought you might enjoy, but don't bother for the exam or this course. So the picture on the left shows a gentleman using TCPIP protocol and the Ethernet physical cabling connection, right? So what TCP does is it has a 3-way handshake, which I show on the right. And that's a process which TCP/IP network uses to make a connection between the server and the client, right? And it's a 3-step process that requires the client and the server. They're actually exchanging information and synchronizing. They're acknowledging each other's packets to establish a connection, which will be called a session. Right? You will have a session then. And be aware of packet switching, right? Packet switching transmits data across these digital networks by breaking them down into little blocks or packets. And this is an efficient transfer using various network devices. So the network devices can then route the packets to the destination where the receiving device reassembles them for use. Again, beyond this class, but just interesting, I thought, and some would enjoy that. So now on this slide, these topics are covered amply on pages 10-12 to 10-15, so please review those there. And again, the slide generally is beyond the course, but again, very interesting for many of you, I have no doubt. Notice that when you use TCPIP protocol, There's such a thing as called packet sniffers, and packet sniffers can be good or bad. On the good side, the good guys can or gals can use them to monitor the logs and the packets going back and forth. We can analyze them later, right, which is a good thing. And it also plays a security role because it can help us identify unusual or excessive network traffic. We actually have software and systems like a web filtering that will open up a packet, review it, make sure it doesn't have anything nefarious by its rules, and then close it back up and send it on. So finally, an IP address, I just wanted to mention. Oh, but no, I did want to say, but the last one is the hackers. The hackers can use a packet sniffer to also, if they can get in the middle of your conversation between the client and the server, that's called man in the middle. And if they can get in the middle, they can use their packet sniffer to look at your packets. They could recode your IP address to theirs, and your traffic could be rerouted as a result to their nefarious server, where they could then hack you or add viruses, etc. So now I just want to mention finally, an IP address can be used to determine a computer's locations, right? You can use a computer or device location from its IP address. Certain websites allow visitors to find a location by entering an IP address, for example. And some web apps, if you don't have GPS available, will use your IP address to approximate your location. That was listed in the book. I just thought it was very interesting because it becomes practical, real world for us. Now, these topics are also covered amply on pages 1012 to 1015. I'll just touch on a few points here. One is Wi-Fi. Wi-Fi uses the 802.11 standard, right? And it matures, so we'll call it 802.1x, x being A, B, C, G, N, etc. This refers to a family of specifications. It was developed by IEEE, one of those standard organizations like ANSI, for wireless LAN technology. So 802.11 applies to wireless LANs, right? And it's going to give us that 1 or 2 megabytes per second transmission over 2.4 gigahertz. I mention that only because when you start talking gigahertz, if you have issues or conflict or errors, say with your laser on the remote control, you want to look at the frequency range. Again, beyond this course, but very interesting. So also the wire Wi-Fi using 802.11 or 11A, 11B, etc. It does frequency hopping, right? And so that actually helps keep things secure. Wi-Fi is sometimes called a wireless Ethernet, just FYI. And we use this Wi-Fi to even create our own hotspots, say in an airport where we want faster internet from our own phone. Now, Bluetooth is a short-range radio waves, usually within about 33 feet or so. It's not a line of sight. And so you can use it even if somebody's around the corner, kind of neat. And devices should be paired, right? And you always want to use a pin to keep them secure from threats like blue bugging. Now, blue bugging is a form of Bluetooth attack caused by a lack of awareness, right? And similar to blue snarfing, blue bugging accesses and uses all the phone features by a hacker. Blue snarfing is a device hack that involves theft of data from your phone, including contact lists, calendars, emails, texts, etc. So we want to make sure we keep our Bluetooth undiscoverable when we use it, and we also want to use a PIN. Now, IRDA is used with remote controls. That's line of sight using infrared light. And RFID uses radio signals to communicate. We're going to discuss that next a little bit more. So RFID technology is technology that works on a radio frequency, and it's used for auto identification for the different for objects. So RFID system mainly consists of just two parts. You have the object on which the RFID tag is attached, and as long as it's within range of the radio waves, it's going to send information to an RFID reader. That's if it's active mode. If it's passive, the RFID reader, when you get within range, is going to reach out and pull that information in. The RFID reader is also sometimes called a transceiver. It's got an antenna that manages its radio signals, right? And again, this is good from anywhere from 5 inches to 300 feet. I've used RFID tags on pallets, cargo pallets that go on an airplane. As the pallets pass the RFID reader, it collects the information, and I know what's on that pallet and where it's located in my warehouse. Was one good use of that. Now, there's another radio signal technology similar to RFID is NFC, near field communication. These are short distance wireless communication technology. So when two NFC enabled devices are close to each other, really roughly around 4 centimeters, I mean close, they can communicate with each other using radio waves. Now, NFC technology allows users to make secure transactions, exchange digital content, connect electronic devices with a touch. NFC technology it can be contactless, and the most common use of this NFC technology in your smartphone is making payments, say, for example, with Samsung Pay. If you rarely use NFC, it's probably a good idea to turn it off, since NFC is very short-range technology. And if you don't lose your phone, and then there is not much security concerns left with it. But NFC is really also would have an effect on your battery. Now, a dedicated line is a type of always on physical communication. Dedicated lines can be either analog or digital, right? Though we're moving more towards only digital. And this slide shows some examples of these dedicated lines. You can read more about them on pages 1016 to 1019 of your book. Whoops, I skipped one. There we go. Data communication now refers to the exchange of data between the source and the receiver. So data communication aims at the transfer of the data and maintenance of the data during the process, like in the packets, but not the actual generation of the information at the source and receiver. And so the highest data transfer rate to date, I think, has been about 14 terabits per second over a single optical fiber. This was done by a Japanese group, NTT, the Nippon Telegraph and Telephone, back in 2006. So very interesting, the level of speeds we are reaching. My company offers service with the right modem for 1 gigabyte downloads, the fastest by far of anybody. A little self-promotion there. Okay. Communications devices enable the transmission of data, instructions, and information. We've mentioned that before. Now, the following slides describe these variety of communications devices, starting with digital modems such as cable, DSL, and ISDN. So we'll pick it up there when we come back on part 3.